Hey guys, and welcome. This week we will be talking about more DSP. We're going to be specifically talking about dynamics. So let's take a quick look. This is a DSP file that I set up, and it has quite a bit going on here. If you guys want to take a look with me, if you've never seen q-sys, this is their UI for their open DSP structure. So basically what I have is I have some signal generators that are going to some routers and my different dynamic blocks that I'm going to be taking a look at today. And then each of those have meters on both the generators themselves, which just flows through the router, and then on each of the pieces of dynamic blocks. So what we're going to do is we're going to dive in and let's take a look at some of these. So first thing we're going to do is we're going to go live to the core. So we need this in order to do our meters. So our first one that we're going to look at today is a compressor. A compressor is very simple. It has very few controls. It has a threshold level, which this is the point at which the input monitors and will start to engage the compressor block itself. And that's what you see here. This is the threshold. So as your input signal goes above your threshold, it then starts to apply the compressor itself. The compressor uses a ratio, and it's a ratio of input to output on how much gain needs to be applied. So the higher your ratio, the more gain reduction is applied, which decreases your dynamic range. This can be very helpful in a lot of ways, but we'll dig into that a little bit later. Your depth. Depth is very interesting. So you can adjust how far this slope for the actual compressor itself goes along your input. So as you reduce your depth, you'll see the chart change where it will no longer be applying compression and it will be a linear increase. It doesn't mean it will suddenly jump back. It just no longer increases that ratio. So if it's applying a negative 20 dB gain, then it just does a negative 20 all the way up instead of increasing that as input increases. And then you also have your knee adjustment. Some compressors have this and some don't. A lot have a switch where you can do a hard knee or soft knee. And basically a hard knee is right at your threshold. It transitions instantly into your compressor ratio. As you increase and soften that knee, you'll see it slope out a little bit and becomes a little bit less intrusive and a little bit softer. You also have attack and release time. So this is how quickly the block itself responds to input. So as it goes above the threshold, this is the time that it takes to engage the compressor. And release time is the same way. How long the compressor stays engaged once the input signal drops below your threshold. So we can actually see this pretty simply. So we have our input and our output. And then you can actually see the block itself and our adjustments. And luckily, it shows us our input level and then how much gain reduction is being applied. So we can go through this and we can see as we reduce our level, you can see it jump down. And right here, we are just below our threshold. So at the peak, we are at negative 37 dB. And here, we're at negative 37. So as we increase our level, let's increase our level to 0. You will see we are at 0 dB. Our ratio is at 3.17, just arbitrary. And then our output is negative 21. So this is how much gain is being applied, negative 21.7 dB. So as we reduce this, you will see how the applied gain reduces as we come down this slope, because it's a ratio of input to output. So what this is useful for is when you have someone who has a lot of dynamic range in their talking voice. As we begin to get excited and talk loud, or if you have a singer that is screaming, it helps reduce that dramatically. So you're not over. It also helps kind of protect your system from overdriving itself. So you get the dynamic range down low, but reduce it towards the top end. So usually you can do a threshold of negative 25 or so, and a ratio of 3:1 for voice. And I'll do a softer knee, nothing too dramatic. And I just leave the depth by itself. No need to change that. So you'll see as we go up towards 0, it is hard for it to actually reach 0 based on our ratio, which helps maintain that level. So we'll increase this to 0. We're applying negative 16 dB. You may want to change this and play with it based on what you're going to be using it for. You can change your threshold around until you get to where you want it to be. So we can actually watch this in progress as our signal will ramp. So we'll take our signal all the way down to negative 50. You'll see as we ramp up, compressor's not engaged, it's our threshold, compressor engages, and you'll see this, and I'll do it in slow-mo. I'll do it one more time, where you'll see the input continually rise linearly, but the output will slow down and exponentially as we hit our threshold. Let's talk about limiters. Limiters are devices that will, very simply, limit your input. So as your input gets to whatever your threshold is set to, it then applies a linear gain to the output. So what this does is, think of it hits a hard ceiling, and the volume will not increase past that. It can be considered harsh at times if you're using it within an audio system, and so it's not really recommended unless it is a last resort system protection device. I use them usually on outputs, where I can protect speakers to make sure that we don't overdrive the inputs on amplifiers or overdrive speakers. So you can see as we increase our level and we hit our threshold of negative 20 dB, this graph stops, our applied gain increases, while our input continually increases. So we'll drop this back down, we'll see it one more time. And our attack and release time, as we hit this threshold, as we increase our attack time, you'll see the graph continue up and then drop down to our limit level. And release time is the same way. As we increase, as it drops below, you'll see the ball move down here and then jump over to this line. So let's ramp up. You'll see the ball go up here and then be applied down as that attack time approaches. And as we ramp down, you'll see it respond slowly, and then it glides into. So these are great for protection. You can use them for drums to kind of help level out the signal depending on how the drummer is playing. You can also use a compressor. So a compressor is very similar to a limiter. Limiter is a compressor with a infinity to 1 compression ratio. That is the only difference. Next we have a gate. A gate is a very simple device. Think of it as a opposite of a limiter. Instead of limiting the top end, it limits the bottom end. So as our signal increases, we hit a threshold and it allows audio to pass like a gate. Instantly, as we hit this threshold, coming back down, as signal decreases, it applies a negative gain, and at this point it is 60 dB, instantaneously. This is used for removing noise from a system and trying to reduce the number of open microphones in a system. In audio theory, as the number of microphones increase, the level in which feedback is going to happen is greatly reduced. So if you have one open microphone and you have feedback at 100 dB, as you increase that number, that level in which you will get feedback is reduced, say 90 dB, 80 dB, as you open up microphones. This can also be used to kind of clean up some specific instruments. You'll have to do your own research on specific ones and specific miking techniques to see what would best work for you. But in a conference room, this helps make sure that you don't have too much room noise being introduced into an audio system when someone at one end of the table isn't talking, but the other end is. You can also see this implemented in gating auto mixers. So a gating auto mixer is just multiple gates on all the inputs, and it intelligently opens up each gate depending on what has the highest signal. And you can just adjust it. So we can watch as our signal drops below. You can see how the bottom just falls out, and our applied gain instantly is applied. And as we slowly ramp up, as we hit our threshold, we suddenly get signal. So you can see how if you don't have this set up right, someone can start to talk and the gate won't open instantly. And so some of their words would be cut off. And so that's where you have to play with your attack, hold, and release times and your thresholds based on your background noise and your type of speaker. Because as you increase your attack time, it takes longer for this reaction to happen. So you want to have a pretty low attack time. Hold time of 100 milliseconds is pretty good, and a release time of 100 milliseconds is great as well. So as we drop out, it slowly falls out. And this is the time it takes for. So as we hit our attack, instantly opens up as we increase. As we go back down, it slowly falls out. As we reduce this release time, we'll bring our signal back up, and then bring our signal back down. And the shorter this release time, the faster the bottom drops out. So having a fast attack time and a slow-ish release time helps kind of smooth that out. Our next one is an expander. An expander is a fancy gate. All it does is, as we hit a threshold, our gain ratio, it slowly reduces the amount of negative gain applied until it opens up. So this is nice. As our signal increases, it makes a smoother increase in audio signal to increase our dynamic range, where a compressor and limiter were used to reduce our dynamic range. Expanders and gates are used to increase dynamic range between our loudest and quietest signal. So these help a lot. I really prefer expanders and compressors over the harshness of gates and limiters. I always suggest using these in designs. Expanders and compressors are used for microphones and audio inputs. You can use limiters and gates for outputs. Gates, just stay away from. You know what? Just stay.